Hello, dear friend. Myself, Dr. Surekha Jaiswal, Head Department of Physics, Moreshwar College, Bhokardan. Today we will see course code number 302, paper number 16, semester 5, Electrodynamics. Now see, in electromagnetic waves, electromagnetic wave equation in conducting medium, and second topic, that is transfer nature of electromagnetic wave and plane polarized electromagnetic wave. Now, electromagnetic wave equation in conducting medium. Wave equation. Electromagnetic wave can be propagated through different media such as conducting or non-conducting. Propagation through conducting medium is the most general case, and the other case can be derived from that by changing the values of sigma, epsilon and mu. In all cases, we derive the propagation constant k, attenuation constant beta, phase shift constant alpha from the wave equation. Now see electromagnetic wave equation in a conducting medium. Now consider a conducting medium of electrical conductivity sigma. Electrical conductivity is denoted by sigma, and permeability mu, and permittivity is denoted by epsilon. Suppose the medium is free from a charge source, then charge density rho equal to 0. Now by using Maxwell 4 field equations are, that is del dot D equal to epsilon del dot E equal to 0, or del dot E equal to 0, or del dot B equal to 0, and another equation, that is del cross E equal to minus delta B by delta T, and also the equation of Maxwell, that is del cross B equal to mu into J plus epsilon delta E by delta T, or del cross B equal to mu into sigma E plus epsilon delta E by delta T. Here J equal to sigma E. For electric field, to eliminate B, vector B from equation 3 and 4, see in equation 3 and 4, here we have eliminate B bar, then we get del cross E equal to del cross minus delta B by delta T is equal to minus delta by delta T into del cross B. Now putting the del cross B value from equation 4, we get del cross E equal to minus delta by delta T into mu into sigma E plus mu into epsilon delta E by delta T, and therefore del cross E is equal to minus mu into sigma into delta E by delta T minus mu into E into delta square E by delta T square. By using the triple vector identity, that is A cross B cross C equal to B into A dot C minus C into A dot B, that is A bar cross B bar cross C bar is equal to back minus cap. Now we get del cross E equal to, so using this identity, that is del bar into del dot E minus E bar into del dot del. So del cross E equal to 0 minus del square E, and therefore del cross E equal to minus del square E, and using this equation 6, in equation 5 we get minus del square E equal to minus mu into sigma into delta E by delta T minus mu into epsilon into dt square E by delta T square, and or del square E equal to mu into sigma delta E by delta T plus mu into epsilon delta square E by delta T square, and this is the general wave equation for electric field E bar. That is del square E equal to mu into sigma delta E by delta T plus mu into epsilon delta square E by delta square T. Now for non-conducting medium, sigma equal to 0, and then we get del square E equal to mu into epsilon delta square E by delta T square, and for magnetic field V bar we have taken the curl of equation number 4, that is this del cross B equal to mu into J bar plus epsilon delta E by delta T, or is equal to mu into sigma E bar plus epsilon delta E by delta T. So taking the curl of this equation we get del cross B bar equal to del cross mu into sigma E bar plus mu into epsilon delta E by delta T, and therefore is equal to del cross B equal to, so taking the curl we get mu into sigma into del cross E bar plus mu into epsilon delta by delta T del cross E. So here del mu into sigma into minus delta B by delta T plus mu into epsilon delta by delta T minus delta B by delta T, and so del cross B equal to minus mu sigma delta B by delta T minus mu into epsilon delta square B by dt square by using vector triple identity, that is A bar cross C bar equal to B bar into A dot C bar minus C bar into A dot B bar. So that is we get del cross B equal to del into del dot B minus B bar into del dot D del, so that is equal to 0 and minus, so B bar into del dot del, that is del square B bar, and that is equal to minus del square B bar. So del cross B equal to minus del square B bar, and putting this value in equation 9 we get minus del square B bar equal to minus mu into sigma delta B by delta T minus mu into epsilon delta square B by delta T square. So we get del square B equal to mu into sigma into delta B by delta T minus mu into epsilon delta square B by delta T square, and this is general wave equation for magnetic field B bar. And for non-conducting medium, sigma equal to 0, then we get del square B equal to mu into epsilon delta square B by delta T square. Now see transverse nature of electromagnetic wave. The electromagnetic wave have no longitudinal component. Let the wave propagates along x direction, then Ex equal to 0 and Bx equal to 0. The electric field and magnetic field variation occurs only in direction perpendicular to x-axis. Now consider wave equation for a uniform plane. We get delta Ez by delta x equal to delta By by delta t, and delta Ey by delta x equal to minus delta Bz by delta t, and delta Bz by delta x equal to minus mu 0 epsilon 0 delta Ey by delta t, and delta By by delta x equal to mu 0 epsilon 0 into delta Ez by delta t. In above equation, we observe that neither the time derivative nor the x derivatives of By and Bz or Ey and Ex vanishes. That means the wave are transfer in nature. Now see proof of this. Now dividing equation 1 by equation 2, we get, see here, after division of equation 1 by equation 2, we get here, that is delta Ez by delta x divided by delta Ey by delta x equal to delta By by delta t upon delta Bz by delta t. After division, we get delta Ez by delta Ey equal to minus delta By upon delta Bz. So our Ez upon Ey equal to minus By upon Bz, or Ez Bz equal to minus Ey By, or Ey By plus Ez Bz equal to 0, but E bar dot B equal to Eb cos of theta, and here theta is angle between electric field vector E bar and magnetic field vector B bar. Therefore here I bar Ex plus J bar Ey plus K bar Ez dot I bar Bx plus J bar By plus K bar Bz equal to Eb cos of theta, and therefore after multiplication, taking dot product of these two brackets here, Ex Bx, that is I bar Ex dot I bar Bx gives Ex Bx, and J bar Ey plus into J bar By gives Ey By, and also K bar Ez dot K bar Bz gives Ez Bz, and that is equal to Eb cos of theta, where I bar dot I bar is equal to 1, J bar dot J bar equal to 1, and K bar dot K bar equal to 1. So we get Ex Bx plus Ey By plus Ez Bz equal to Eb cos of theta. But Ex equal to 0, Bx equal to 0, or Ex Bx equal to 0. So we get Ey By plus Ez Bz equal to Eb cos of theta. Hence Eb cos of theta equal to 0. So therefore equation, that is from equation 5. Therefore cos of theta equal to 0. Therefore theta equal to pi by 2 radians. Thus E bar and B bar are at right angles to each other. Now plane polarized electromagnetic waves. Now electromagnetic wave consists of electric and magnetic field vectors oscillating in mutually perpendicular direction. With electromagnetic wave, in electromagnetic wave will be perpendicular to both the oscillating electric field and oscillating magnetic field. These electric and magnetic field are perpendicular to the direction of propagation of the electromagnetic wave. When variation of electric and magnetic field are restricted to a single plane, then the electromagnetic wave is called as plane polarized wave. That is definition of plane polarized wave. When variation of electric and magnetic field are restricted to a single plane, then the electromagnetic wave is called as plane polarized wave, and the wave can be polarized or transfer wave. Hence, electromagnetic wave can be polarized and are transfer in nature. Now consider electric component E bar, see in figure, and magnetic component B bar are perpendicular to each other. See, that shaded portion of the wave, see in figure, that is the electric component as shown in figure, that shaded portion, and another component, that is magnetic component B bar, here shown in figure. So are perpendicular to each other and also perpendicular to the, that is the direction of propagation. So that is also perpendicular to direction of propagation, and hence electromagnetic waves are also a transverse wave. In figure, the shaded portion shows you the electric field oscillations, and the shaded portion that is shown in figure, see, that gives the oscillation of the magnetic field vectors, and direction of propagation of the wave is perpendicular to both these vectors. Now let us consider a plane wave traveling along x direction in a medium. Then mu 0, that is permeability of the medium, and epsilon 0, that is permittivity of the medium. Also J bar equal to 0, and E bar and B bar vectors are lying in YZ planes. Now if EY equal to 0, EZ present, the wave is said to be polarized in Z direction. In this case, magnetic field vector will be along the Z axis, that is Vz equal to 0, and consider wave equation. We have del by Ez by del by x equal to del by 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 del by t, that is del by Ey upon del by x equal to minus del by Bz by del by t, and next, that is del by Bz by del by x equal to minus mu 0 epsilon 0 into del by Ey by del by t, and del by By del by x equal to minus mu 0 epsilon 0 del by Ez by del by t. Put Bz equal to Ey or is equal to 0 in equation 1 and 4. We get del by Z by del by x equal to del by by del by t, and del by by del by x equal to mu 0 epsilon 0 del by Z by del by t. Now taking the del by del by x of equation 5 and del by del by t of equation 6, we get, so taking this equation 5 here, del by del by x of this del by Ez by del by x is equal to del by square Ez by del by x square equal to del by square By by del by x dt dash. delta t, and delta square by delta x square equal to mu 0 epsilon 0 into delta square Ez by delta t square. So from equation 7 and 8 we have delta square Ez by delta x square or is equal to mu 0 epsilon 0 delta square Ez by delta t square. Above equation shows wave equation for Ez for a charge-free non-conducting medium. Now taking delta by delta t of equation 1 and delta by delta x of equation 2, we get delta square Ez by delta x delta t equal to delta square by delta t, and delta square by upon delta x square equal to mu 0 epsilon 0 delta square Ez by delta x delta t. Now from equation 10 and 11 we get delta square by upon delta x square equal to mu 0 epsilon 0 delta square by upon delta t square. Above equation shows wave equation for By of a plane polarized electromagnetic wave. Now the solution of equation 9 is Ez equal to minus epsilon E0 into sine of 2 pi upon lambda into V into t minus x, and equation 12 of solution is By equal to V0 sine of 2 pi upon lambda into V into t minus x, where E0 and V0 are the maximum value of E bar and V bar respectively. And so from equation 5 and equation 30 becomes delta Ez by delta x equal to delta By by delta t. Therefore delta Ez by delta x equal to minus E0 into 2 pi upon lambda into cos of 2 pi upon lambda to Vt minus x. And from equation 14 we have delta By by delta t equal to minus V0 2 pi V upon lambda into cos of 2 pi upon lambda into Vt minus x. Now putting the value of B and C in equation A, we get minus E0 2 pi lambda cos of 2 pi lambda into Vt minus x equal to minus V0 2 pi V upon lambda into cos of 2 pi lambda into Vt minus x, or minus E0 into 2 pi upon lambda equal to minus V0 2 pi V upon lambda, or E0 equal to V0 into V, or E0 V0 equal to V, or E0 H0 equal to mu into V. Now but V equal to under root of 1 upon mu into epsilon, so E0 B0 equal to under root of 1 upon mu into epsilon, or E0 upon H0 equal to mu into under root of mu into E equal to under root of mu into mu upon epsilon. Thank you.